Hi again. In this short video, we're going to start by asking the question, well, what is pain? It used to be the case that we were very clear about what pain was. There was a chap called Descartes who uh, had the idea that if we burnt our foot, for instance, in this situation, then what would happen is it would create a sensation in our foot, which would then travel up effectively a single wire to our brain, and ring a bell in our brain, which would say whether it's something tell us that we were doing ourselves some damage, and it would encourage us to then remove our foot from the fire. And for many years, that was the way we thought about the pain. And it wasn't until the beginning of the 20th century that people really started to question whether this was actually the correct way of thinking about things. What they started to do was they started to notice some problems with the single wire theory. So, for instance, the single wire theory would suggest that if you have a large amount of pain, then you have a large amount of damage, and vice versa. However, when they started looking at soldiers, for instance, who were injured on battlefields, what they started noticing was that in certain circumstances, people could have the most horrific injuries and not experience a lot of pain. And equally, on a much more mundane level, they also started realizing that people could have a very small amount of injury and yet have quite a large amount of pain. And you may have experienced this yourself last time you had a paper cut. It's a very small injury, but God, it can really hurt. So we started thinking, well, hold on, there's something not quite right here. Another thing that people were starting to notice as well was something called phantom limb pain. And this is where someone experiences pain in a limb that has been amputated. And again, you think, well, with a single wire theory, well, if the wire's not there and the limb's not there, then there's obviously nothing to generate that sensation. So the question then is, well, what's going on there? And you may have experienced something similar to phantom limb pain yourself when you go to see your dentist and they inject something in your gum, and you start to fit the pain gets very, very numbed. But actually, you can actually experience quite a different sensation. So what actually happens is that it feels as though your face is twice the size it normally would be. And so we start to realise that actually even on a almost sort of on a regular basis, we can start experiencing symptoms and things that aren't based on what actually is happening with our bodies. And this obviously gave people a lot of cause to stop and think. Another thing that's quite interesting is the concept of referred pain. And this is where people experience pain in a part of the body which is different from where the actual problem is. Quite a common example would be if when people have problems with their heart, having a heart attack, often they will feel pain in their jaw or their arm or shoulder rather than actually where the heart is. And this is known as referred pain. Another example would be sciatica, where people experience pain down the back of their leg, when in reality the problem is in the back, at the bottom of the back. So again, this doesn't quite fit with this single wire theory, and so people were starting to sort of question whether actually there might be a bit more going on than was actually thought about. And then finally, it looked at there's a issue where some people actually are unable to feel any pain at all, either called chronic insensitivity pain or congenital anesthesia. And in this situation, something happens to the genetic structure, which results in the person not being able to actually experience pain. And if you're a pain sufferer yourself, you might think that's actually a pretty good thing. However, unfortunately, people with this condition have actually a much shorter life expectancy, because as a result of not experiencing pain, they're much more likely to damage themselves, and if they have something going on inside their bodies, such as a broken bone or something like appendicitis, then unfortunately they are unaware of it until it's often too late and they've caused themselves some horrible damage. The other thing about this is that we start looking at things like X-rays, and so we've got an X-ray on the screen, and you might think that as a professional, you can look at that X-ray and say whether that person has got pain or not. But actually, we can't. Often we're no better than chance to be able to look at an X-ray and see whether someone's got pain, because having it changes on an X-ray that for one person might cause pain does not necessarily mean that someone else with exactly the same changes will experience the same thing. And so we start to realize that actually there's a very, very poor correlation between what's going on in our body and the pain we experience. And that started encouraging people to really think about the process of those sensations getting up to the brain. And people started really thinking that actually there must be something a bit more to it. So when we say now, what is pain? It's not this single wire theory that we're actually working on anymore. And in a future video, I'll talk to you about something called the gate control theory of pain, and look at actually some of the things that that we now know that mediate that message going from the foot or anywhere else in the body to the brain. And now the current idea that we have of pain is much more about tissue damage, obviously is part of it, but also the way we behave, the way we communicate our pain, the way that other people around us respond to us when we're in pain, and a whole series of other issues besides. So the International Association for the Study of Pain published a definition of pain, and this is it. Pain is an unpleasant sensory and emotional experience associated with actual or potential tissue damage, or described in such terms. And if we go through that in a bit more detail, we can see that actually there's quite a lot that's going on rather than just a single wire. For a start, it says that pain has got to be an unpleasant sensory experience. Now, there is some debate about whether that actually is the case, because for some people, in some situations, something that is a noxious stimulus can actually be regarded as pleasant. But that's for another day. The other aspect of that is it's a sensory experience, so there's very much involves the nerves and the nervous system in the human body, but it's also an emotional experience. And it's so often people sort of say, well, it's all in your mind, or it's a real pain. In reality, there isn't such a thing as something that's all in the mind or all in the body, because the brain and the nervous system are all on one and the same sort of system. The two things intermingle and they certainly have a major impact on each other. In fact, when we look at what happens in the brain when people experience pain, and this is a study back from 2005, the areas that you can see on the screen which are coloured in are all the different areas that light up when someone experiences pain or describes that they're in pain. And so we can see that actually there isn't such thing as a single pain centre in our brain. Rather, that what actually is going on is we have a pain matrix in our brain, and a matrix of things which interact with each other and influence the way we perceive the world around us, and particularly the pain. And the other thing that's important to bear in mind here is that this isn't just a one-way process, because actually what's going on in our brains also feeds back down through the various different aspects of the pain system, and can have an impact on actually the way that those sensations are processed on their way through the nervous system. More of that in another video. So we then move on to thinking, okay, well, so we know it's an unpleasant sensory and emotional experience. We know it's affecting all sorts of different parts of our brain, and certainly some of those parts of our brain that were lighting up when we see the pain under an MRI scanner. Say actually that's we're the actual emotional centers of our brain we're being lit up. So it's associated with actual or potential tissue damage. Actual tissue damage, yes, okay, we're aware that if we stub our toe or cut our finger, that's fine, that causes pain. But potential tissue damage? Well, actually, there's growing sort of evidence that people do experience pain either before tissue damage or if they think tissue damage has occurred. So, for instance, when someone is going to stick a needle in your arm, often you will experience pain before the needle actually breaks the skin. Perhaps another mundane issue is if you're getting out of a chair and you're expecting your knees to hurt when you do so, then actually they're much more likely to experience pain, even if you have exactly the same pathology as someone who doesn't. Because we believe or we expect pain to occur. And this is another example of how this works in terms of an experiment using a PET scanner, which shows electrical activity in the brain. Now, we've got three brains. On the left-hand side, you've got a brain which is someone's holding a high thermal lance, in other words, a hot rod. And you can see that a large bit of their brain lights up. And then in the middle, there's someone holding a low thermal lance, or a slightly cooler rod, basically. And you can see that it's a smaller area that lights up. And then you come to the third brain, the one on the right-hand side, and ask the question, well, okay, so what do we think is going on there? It's a large bit of the brain that's been that's lit up there, so therefore it must be a high thermal lance. Well, as you can probably gather from what I guess probably by now from what we're talking about, that isn't actually the case. In this situation, what actually is happening is that someone is holding a low thermal lance, but they were told they were going to be holding a high thermal lance. In other words, the brain is responding to what it expects rather than what is actually happening in that situation. And this whole idea of expectation and perception of what's going on also has a major importance to play, because actually often people describe their pain not by actually what's actually happening, but actually in terms of potential tissue damage. So, for instance, people often refer to pain as being a stabbing pain or a ripping pain or a burning pain. And certainly, if there's some evidence that if the more evocative the description is that you use to explain the pain, and particularly if you're describing it in a very damaging or a very threatening way, then you're much more likely to experience higher levels of pain than if you perhaps talk it down, or you just use nice, straightforward terminology to describe what's going on in your body. So, this is a chap called John Bonica, who's one of the famous sort of scientists studying pain, and he says that pain is no longer considered exclusively either as a neurophysiological or a psychological phenomena. Such a rigid dichotomy is obsolete because pain is now recognised as the compound result of physio-psychological processes whose complexity is almost beyond comprehension. Wow, so what we're dealing with here is something that's complicated, and it certainly shouldn't be reduced to being something that's just about a cut finger or a broken bone, or indeed something that's all in the mind. And what's particularly interesting about this quote is that it's not something that's just come up. This is a quote that comes from a book that John Bonica wrote in 1953. So this is something we've known about for a while, and yet we are still learning every year new and interesting things about the way that the pain system in the human body works. And one of the things we're learning time and time again is that actually it's even more complicated than we thought, even in 1953.